This is part 2 of the Mindcuber series. In part 1, I introduced a robot, showed a basic video of it solving a cube, introduced each of the parts, and talked a little bit about failures and problems. This is part 2. I'll be talking about the code, more deeper into problems and failures, as well as a little about the building process. If you haven't watched that first video, I recommend that you do. Let's get right to it. The language that I use to make this work is not actually the Mindstorm's block language normally used with LEGO EV3. It's in Python. So before I tell you exactly how I use Python to control the EV3, let's first talk about my process. I first tried the Mindstorms version, and it actually worked. However, the problem is that with the drag and drop block structure, the software was made to keep the code simple. However, with a complicated program like Mindcuber, it gets complicated fairly quickly. So I set out to use Python. I've had experience with Python before, so the code should be fairly easy to understand. The app that I'm using it in is VS Code. Actually, in VS Code, LEGO recently released an official program from Python to EV3, and I recommended you to check it out if you're interested in that. However, when I went online and found a few Mindcuber Python programs to use, they were all using the older version of Python to EV3, which is called EV3 Dev. EV3 Dev works well, but it's just not compatible with the official LEGO program. But anyways, I used EV3 Dev, importing the code into VS Code, and having a software called Putty. Putty is a terminal program that talks to the Linux program in the EV3. It's easy to use, though it takes a while to load into the robot. Anyways, the code has to use Putty sort of like a bridge to be able to talk to the EV3. This works well, and it's what I've been using for the Mindcuber. Now, on to the code. There are about 500 lines in the code. The code actually doesn't calculate the moves in solving the cube. It uses another program called Koshiyama Cube Solver. It gets the colors, sends it to the Koshiyama solver, gets the moves back, and tells the robot what moves to do. I won't explain the entire code. There's code for flipping, turning, everything, but there are some of the more important parts. This is the scan order of the scanner. Each little square of the cube is assigned a number, and this is the order that it will be scanned in. There are 54 numbers in total, and there are also 54 squares in total on the cube. When it's done scanning, it actually doesn't record the colors as red, orange, blue, etc. It records them as U, D, F, L, B, or R, which stands for up, down, front, left, back, and right. That's right, each color is now corresponding to either U, D, F, L, B, or R, which is the center square that is the same color as. So for example, if a square is assigned U, up, then it means it has the same color as the center square on top of the cube. If it is L, then it has the same color as the center square on the left of the cube. That's the basic scanning and solving part of the cube. There are a lot more parts about the motor movements, scanning, and more, but I won't talk too much about that. Here's a video of Putty downloading to the EV3 and running it. I've also had many problems, modifications, and failures during the process. One of the earliest ones, even before I started the Mindcuber adventure, was that the battery would run out on the EV3 brick very quickly. It would be 6 batteries at a time, and it was using a lot of our batteries. So I made this wire that hooked up to the battery port and then connected it to a plug, so we could just plug it in every time that we wanted to use it. The only time that this wouldn't work was if the robot was moving around, but the Mindcuber was a stationary robot, so it doesn't matter as much. Like I said in the previous video, there was also a lot of jamming with the cube and the flipper. Either the flipper would sometimes flip too much and go off the edge of the cube, like this video. Or it would flip too little and have the cube back where it started. That would mess up the solving process by a lot. The code that I downloaded wasn't perfect, so I had to modify a lot of the code. The degree that the flipper rotated had to be perfect, not too much, not too little. I also had problems with the cube turner. Sometimes when I turned the cube, it wouldn't turn all the way, or it would turn too much, so the cube would end up looking like this. just wasn't aligned, and the flipper would not be able to flip it. I also had to fix this one by modifying the code. These were the two major problems I encountered. The other ones mainly required hardware fixing. I had to remove certain parts because the cube turner or the box was hitting it when it turned. I also had to tape the wire because it was getting in the way of the flipper. When I first built the cube actually, I was missing a very important piece of the box or cube turner, so I had to improvise and create a new box with the remaining resources that I had. I later did find the piece I was looking for, but it was too much work to put it back, and my improvised box was doing just fine. Well, that's it for today, and I hope you enjoyed. This experience was really fun, and like I said before, I strongly recommend to you too. Goodbye, and I'll see you next time.